Okay, lecture number 6. We will discuss about how do we take into consideration the feedback from the user, and then how actually the movement of direction from one position in the search space to a better position in the search space for more relevant document. So we want to visualize what happened when you change the query, or when you put up query with respect to the relevant and non-relevant document. So in most cases, like when we put up our query, we tend to change our query depending on the return result of the document for us. So if we cannot find any important document or relevant document, we tend to make or reformulate our query. In most cases, they will give us some suggestion. So this is based on a number of hits. So they will give us the suggestion list that we have as shown here. Okay. So the first query formulation should be treated as an initial attempt to retrieve relevant information. So what happened is that we put in the query, and then the algorithm will search and rank the document and present to us. And then what happened is that we will click on the document that we think relevant with respect to the query. So this is normally what happened. By doing that, we actually also providing feedback to the system which document are relevant with respect to the query. Okay. So the process of query modification is commonly referred as relevant feedback, in which the user provides information which document are relevant to the query. Or we can expand the query, adjust the query when information related to the query is used to expand it. Okay. So when we type in query, we may be given some document. So for example, before and after. So we are given this 4 document. So what happened is that when we reformulate the query to get better result, so it will be moved to that position. Okay, so this is the assumption that we made. Whenever we reformulate the query, we assume that the location of your initial query will be moved to the nearer to the positive document, which is nearer to the relevant document. Okay, so you can see the movement from the initial to the new expanded query. There are 2 basic approaches that we can use for feedback. The first one is explicit, and the second one is implicit. Explicit means we get the feedback directly from the user manually by filling in the form or showing indication manually to us. So we collect data from them. The second method is called implicit feedback, because they are collecting the information based on our behavior. So we can click, or the eye movement captured can be done using camera, looking at our eyes, the black eye pupil, and then try to look at where is the direction of where is the attention that we paid on the screen. But in most cases, they are looking at the click behavior. When we click on a certain link, then that is considered as important with respect to the query. So we have explicit and we have implicit. Okay, the framework of the relevant feedback can be defined as follows. So basically what we have is, we have document that we click and we look at the term belonging to the top document in the result. So these are the terms that normally used to describe. So in the feedback cycle, we compose two basic steps. So the first one is through survey, we get the input from the user directly, or we can capture the clicking behavior, where we click on the screen to see the document. And then we will determine how to transform the query to take the information. So this is how it happened. Initial query and then transform into the transform query. So for the explicit relevant feedback, the feedback is provided directly by the user. This is time consuming. So for that reason, it is better to study the user click rather than getting the input from the user. So for example, this is the result given to us based on the query, and they will tell us which document are relevant, and then they modify the user query again based on the document that we have. And similar to the clicking, so the clicking is just to indicate that the document is relevant. And we have the same process here. So the left one is explicit, the right one is implicit. Explicit one, we interview them. The implicit one, we capture the clicking behavior. So for the implicit one, we have the local analysis and we have global. So in the local analysis, we derive this based on the feedback from the top ranked document. Okay, this is given to us. So based on the document, we analyze. Global analysis is based on external sources. This is how we describe them. So this is based on the local analysis. We look at the top ranked document that we have. Okay. When we compare to the global analysis, we are referring external resources like thesaurus, document collection, and so on. So we will focus on the left-hand side, which is the local analysis, because in the global analysis, we need to have external resources. So assuming that we do not have many resources, we only look at what we have. So we focus on the local analysis. Okay, so the idea is when we have the explicit relevant feedback, we will have list of documents and the user will mark those which are relevant to the query. So what we need to do is, based on the mark document, we will extract the important term. So we use the term to associate with the document later on. So we select important terms, and then we will enhance the importance of this term in the new query. So we make these important terms as term that can be used to extract this document. So for example, if we type in X, then we have this document. So beside X, we also can use Y and Z, because this is extracted from this document. Okay. So this is explicit relevant feedback. To illustrate this one, we need to study Rocchio method. So we need to look at where is the initial position of the vector before and after knowing the number of relevant documents that we have in our collection. So we will study this Rocchio method. Early experiments have shown good improvement in precision for small test collection when we use this Rocchio method. So we need to know what is this Rocchio method. So basically, what we need to consider here is we need to know what are the vectors for relevant document and what are the vectors for the non-relevant document. So these two are the two main components. We need to know where is this relevant document, and also we need to know what is the non-relevant document. Because the idea is we want to move closer to this relevant document and away from the relevant document. Okay. So for example, if this is our initial query, the red one, and we know that the O is all the non-relevant document and X is non-relevant document. So what we want to do is we want to move to this direction. So we do not want to move to this direction because that is away from the relevant document. Okay. So basically, when we are at this position, we want to go to this direction. Basically, we want to add, and we want to eliminate all of this. So we need to do the minus operation. Oops, sorry. So I want to add this positive, and we want to minus this negative. Okay. So what is the formula for the Rocchio? So they will use the same assumption here. Okay. So we want to know set of relevant document. So assume this is our relevant document. And of course, we also have the number of document that we have in the relevant document. So this is the size of the relevant document. The second one is the non-relevant document, which is not important with respect to the query, and we have the size. Okay, and together this is the all of the document that being retrieved. Okay, and we have the size also. So the all retrieved document comprises of both relevant and non-relevant document. So what we want to do is we want to move nearer to the relevant document, which is this one, and away from here. So we want to be around here. So again, we have all the number of documents. So this is the one that is not retrieved. Okay. So when we look at the condition that we have, consider that we have the set of relevant document. We also have the set of all of the document that we have. So when we want to optimize the query that we have, so we want to eliminate all of these non-relevant document because we consider as this as the relevant document. So when you have all the document that you have minus the relevant document, so the remaining one will be the non-relevant document. So this is the relevant document minus the non-relevant document that we have. Okay. So to illustrate this one, so the dark gray one will be the relevant document, and this one is the non-relevant document. So the vector that we have for the relevant document, we assume to be like this, and then the non-relevant document would be like this. So when we want to optimize the query, so we want to minus this from here. So this is the minus, and our query will be from here going to here. Okay. So that is from the blue one minus the red one, then we get the green one. So this is without any query, but let's suppose we have the query. So this is our query. So we know that the relevant document is this one. So we plus that one and minus this, minus the relevant document. So this is the modified query that we have. Okay. So how do we apply this one in the actual calculation of our TF-IDF? So this is the formula that we have. And this is the standardized one in which we have the, this is without the query, this is with the query. Okay, so this is with the query. So we have a scala here, and the value are standardized to be, okay, for the alpha, it will be 1, beta will be 0.75, and this is a gamma, I think, 0.15. So they have the constant value here. So we don't have to worry about this value. So we know how to compute the vector for Q. We know how to compute the vector for all the document. So they can be classified as relevant and non-relevant. Okay. So to give you an example, for example, if we have this. So this is our query with respect to certain term. So these are the weightage. Okay. So with the query, the blue one denotes relevant document. So this is your relevant document. And this is your non-relevant document. Okay. So first, we need to determine what is the vector for both relevant and non-relevant document. So based on this formula, basically we are taking the average only. Okay. So we will have two vectors. One is relevant and the other one is non-relevant document. So we have these three vectors already: Q, relevant document, and also non-relevant document. So we will apply the formula here. So we will apply the formula. So the modified query will be this. So this is to illustrate that how do we modify the query to be near to the relevant document. Okay, so we adding the vector for the average weightage of the relevant document, and we subtract the average weightage of the non-relevant document. So this is how it happened, how it automate the process of moving your initial query to the modified query. Okay, so I leave you with some exercise here. So normally, given the query here, then we need to compute what is the direction of the relevant document and what is the direction for the non-relevant document, and we just use the formula. Okay. Okay. So for this session, the Rocky method is very important because that is the process on how do we compute from initial query to the modified query. So now we look at the explicit feedback through click. So this is, we are looking at how do we actually looking at the clicking behavior. So basically we are looking at, we want to define a framework that define the behavior of the user. Because we are given, for example, 10 or 15 lists, 10 or 15 document in the list. So when we click the document, it will, we have to make some assumption. Okay. Okay. For example, given the query and also document, so query I and document J. So when we click, we have to mark that that document is important with respect to the query. So if we click certain document, which is the K document, so we will mark with this symbol. Okay. So R1, R2, R3 represent the first, second, and third result. So if we have the list, for example, like this, so that means we only clicking 3 documents here. The result number 3, result number 5, and result number 10. Okay. So what can we make assumption here? So they have defined 2 types. Okay. So this behavior does not allow us to make definitive statement about the relevance of results R3, R5, and R10. So we cannot assume that this R5 is more important than R10, or R5 is more important than R3. What we know is that the user clicked R3, R5, and R10. But we can make assumption for the other result. So we have 2. The first one is skip above, and the second one is skip previous. Okay. In the skip above, it tell us that when we click this R3, that means the rest of this is not important. So if we click R10, so R9, R8, R7, R6, R4, and R2, R1, not important. But we cannot compare with this. Okay. So that is skip above. Skip previous only look at the previous document. So for this one, we say that the R10 is more important compared to R9. R5 is more important compared to R4. R3 is more important compared to R2. So this is skip previous. Okay. If we use skip above means the rest of these are not important if we use R10, but this is not included. Huh? Okay. So this is the step 2. So for the skip above, we are looking at the remaining of the document. But for the skip previous, we only look at the previous document. So this is the framework that we can use to make assumption about the document. Skip above or skip previous strategies. So this is for simple case. We also have like what we call it a query chain, in which we put up a query, but we didn't click anything, and then we modify the query. The second query give us this list, but we click the second and the fifth. So this is what we call the query chain. First query, we did not make any decision yet, and then we change our query, the second list, then we click the document. So how do we define the relationship between this document? Okay. So we have two methods also. So this one, what we can say that the RJ referred to an answer in the first result. So this is the first result. This is the second result. So what we can say is that, okay, we have top one no click earlier and top two no click. So we have two strategies here. This, okay, for the top one, no click, if there exists in the second list such that they are clicked, then this is more important than R1. So for example, here, according to the first strategy, so if we are clicking S2 here, then we say that this SJ is more important than R1 because we have R1 and R2 and so on. Okay, so S1 greater than R1, S2 greater than R1, and so on. So all of this is better than R1. R1 is the result from the first list. So that one is top one. Now click. Okay, top two no click means that, okay, so we have this. So we are looking at the top two. So top two here. So if we click on the second list too, a second list of document, so we are saying that the S1 is better than the top two that we have in the previous list. So it will be repeated, or we assume the same for all the document in the second list. Okay, so that is the assumption that we can make. So this can help us in trying to do the ranking. Okay. Okay, now we look at the implicit feedback through local analysis. So in local analysis, we will use the clustering or gathering approach. So local analysis consists in deriving feedback information from the document that we retrieve given query queue. So we have two methods here. So the first one is called local clustering. So basically, we apply the technique that we have used before, term-term correlation. So what happened here is that we are adopting the clustering technique for query expansion. So the standard procedure is to quantify term correlation. So if you recall back, we have term correlation, right? So what happened here is that we use the term correlation to do the local analysis. Okay. So for example, if we have, this is the same definition that we use. So we have this matrix, which is the term document matrix. And we take the transpose, we times, and this is what we call the term correlation matrix. So if you recall back, what we have is we just transpose the matrix, get the multiplication. So the value that we have here express the correlation between term U and V. Okay, so this relationship between the term is based on the joint co-occurrence inside document. So if we type computer, okay, so based on this analysis, we always come up with computer science or computer engineering. So those are the words that we use to expand. So from computer, they expand to computer science because they always come together, right? And also computer engineering. Okay. So how do we get this? This is they are all obtained using the term correlation. Okay. So based on this calculation, they look at the value that we have here. So the value here will determine how strong they are correlated to each other. So by using this correlation, they expand the query from a single one, from X, okay, from X to Y. Let me change this one. So from X, they expand to X and Y. Okay, how do we get the Y? This is based on the value that we have here. So we can tell that two terms always come together. So we use that term to expand our query. Okay. So that's how we use term correlation. So this is the previous exercise that we have, but last time I used 1 and 0, but this one they have weightage. Okay. So again, I will leave you with this two exercise. I think two exercise. One is the Rokyo. So you can access this in the ITEL. So we will do we will solve the solution together. Okay. So have a look at this. And then please share your solution later on. So the time now is 10 to 12. So we meet again around 1 o'clock. Boleh kah? 1 o'clock. So we have two. So one is this one, and the second